Mechanicsville crew, this is Eddie, the Commish, here in Pop's Garage. We're going to give you another Mechanicsville minute here. We're going to talk some tech today. We're going to talk about carburetors. As you saw in the video the other day when we cranked the Bel Air up, that vehicle is equipped with a carburetor on the engine. That's what we call old school technology. I don't know if I can pull this off today talking about a carburetor because I don't have on a pair of New Balance tennis shoes or a pair of jean shorts. It seems to be a prerequisite to work on a carburetor or tune on a carburetor to possess a pair of New Balance tennis shoes and a pair of jean shorts, but I'll do the best I can. Carburetors in particular, we're going to just give you a brief overview today of the carburetor, and then we're going to move over to the Bel Air. We're going to actually remove the carburetor. We're going to give you some video of changing the jets in the carburetor, and we're going to show you some video, some little tech tips over there on the Bel Air. But basically just talking about jetting a carburetor today. Like I said, just a very brief overview of a carburetor, what a jet is, what it does, and then changing the jets and the reason why we're going to change the jets. A carburetor, just in basic terms, is how the fuel gets atomized. That is the function of the carburetor in and of itself, is to atomize the fuel with air so that that can be drawn into the intake system, then mapped out into the different cylinders based on the stroke of the engine and which valve, which intake valve is open, and move that atomized fuel mixture into that cylinder, then to be burnt during the combustion process to produce power in the internal combustion engine. That's where the internal part of the combustion engine lies, is the burning of that atomized air and fuel mixture. Now, what a carburetor does to do that is it acts on what's called a Venturi effect. And this is partly how and why a jet comes into play here. I'm going to pull a little chart over here. I hope you can see it. Something I worked on earlier. So the Venturi effect takes place inside of the body of the carburetor, where you see this channel that draws incoming air into the engine narrows to a specific point. Well, a physical principle causes the speed of the air to pick up as it moves through the Venturi, causing a drop of atmospheric pressure. Now, in the fuel bowl, this is not exactly the way a carburetor is truly laid out, but just in the simplistic terms to show you how this works. The fuel bowl is here with basically the weight of the fuel and atmospheric pressure on top of the fuel. The jet is located here, and as that air speeds up and causes a vacuum here at the inlet port of the end stream here, the atmospheric pressure and the weight of the fuel then is pushed through the jet and into the airstream, and mixed, then air and fuel goes into the intake to be distributed. See if that's. This would be your throttle blade. It would be working back and forth to manage the airflow coming into the carburetor, and that, when it moves through this narrowing portion of the carburetor, this is what actually causes the air to speed up, or the Venturi to speed up and then draw the fuel into the stream. Once it's drawn into the stream, it is then put together with some air, the air that is coming into the carburetor, and it becomes atomized. Because atomized fuel is the only thing that will burn. A raw fuel, if there was a way to keep it from not releasing any type of fume, you can see the waves coming off of raw fuel. If you see that out in the sunlight, you'll see waves. That is actually evaporation taking place of the fuel. That's what makes gas, alcohol, any type of flammable liquid, that's what makes it volatile. That's how it produces its power, is the volatility of it. So that Venturi effect draws the fuel into the airstream. The fuel is married with oxygen, and then it is brought into the intake and then distributed out through the intake runners to the particular cylinders that have the valves, intake valves, open at that time, to then be drawn into the cylinder, squashed during the compression stroke, ignited by the spark plug, and then burnt to produce the combustion process. That is where we get the term internal combustion, because all of the combustion happens within a chamber inside of the engine. And it can be as many cylinders as you desire the engine to have. It can have one cylinder, such as a lawnmower engine, up to 4 cylinders, a small motorcycle engine, or a small car engine, 8 cylinders, 10 cylinders, 12 cylinders. It can have as many cylinders as the engine designer desired. Now, one of the ways that we work that fuel into the airstream is through that jet. Now, a jet is basically a nozzle or an opening that allows the atmospheric pressure and the weight of the fuel to pass through that once that Venturi effect has sped the air up in the throat of the carburetor. The diameter of the hole is it's not just a diameter. The number of how jets are classified are by number. The number does not directly correlate to the actual diameter of the hole, but the amount of volume that can pass through that hole. So that in and of itself is how the jets are determined in size. So a jet with a large number has the ability to flow a large amount of fuel. A jet with a small number or a smaller number has the ability to flow less fuel. Therefore, leaning it out or richening the air-fuel mixture up depending on which way you go. Lean with a smaller jet diameter and rich with a larger jet diameter. Now, why am I speaking about jet diameters and lean and rich conditions? Well, a carbureted engine does not necessarily have the advantages of modern technology, such as an oxygen sensor, which is downstream from the exhaust manifolds that come off of the cylinder head, to read that air-fuel mixture and know how close it is to a stoichiometric or a perfect air-fuel ratio. So we have to look at plugs on a carbureted engine and tell the difference between a rich or lean condition. Now, the reason I brought that up is the other day when you saw us crank the video, the cranking video of the Bel Air, after it cooled down, we'd run it a little while after we cooled down. This was post-production. I actually pulled a plug out of the cylinder head and noticed that it was very sooty. I'll have Ash will put up a picture of the actual plug that I pulled out of the engine. And the sootiness is a direct relationship to a rich fuel mixture. There are 7 circuits in the carburetor, and if you want an in-depth overview and me to go over the carburetor in depth, drop a comment below the video. We'll look at those and we'll see how many people have an interest in that, and I may do a video later on, get Ash to help me produce a little bit better video of just a carburetor, what it is, what it does, how it functions, and the parts and the circuits, how it actually operates. And we could do that in a later video. Like I said, the reason I'm doing this video is because we're going to do a little bit of a hands-on technical demonstration over here in a few minutes, because I feel the need that we're going to have to jet this carburetor down, as it's leaving a very sooty afterburning on the tip of the plug when it's removed. And this is just from idling the car. So the car, being in car shows, maybe parades or something like that in the future, if the car is going to idle, it would have, with a rich mixture like that and being in a long-term idling situation, that would have the tendency to foul the plugs, which means that soot builds up on the end of the plug at such a degree that it allows the spark to actually go to ground before it ignites the air fuel mixture in the cylinder. And that's not what we want. We want those plugs to burn clean so that it'll idle smooth. The closer we can get to a perfect fuel ratio, the cooler the engine will run. It just has a lot of advantages. Now, as I said, a carburetor or an old school carbureted engine does not have the advantages of the technology that's available for the computer controlled engines that we have today in late model cars. That would take care of that automatically. So what we have to do with an old school carburetor is we have to read plugs, we have to look at the combustion chamber, we have to look at the exhaust color, and we basically determine how we're going to run that air fuel mixture based on those corresponding observances. Now, what is a jet? Let's talk about a jet. Right here I have a kit that's available from Holley. It has several jets from a particular size to a larger size, from smaller to larger. They're mapped out on the top case of the case here, and I hope you can see this pretty well, but it starts with a 64 and goes up to a 99. Now, these, as I said, the diameter, and I'll get a picture of the jet, a close-up picture of the jet and the number on it, so you'll be able to see what I'm actually talking about, and ask you to drop that in there. But the diameter of the hole is basically what I'm referencing is the volume that will flow through the hole in the jet. So we would start out with a very lean reading with like say a 64 versus a 99 up here, which has a much larger hole in it, which would allow much more fuel to enter into the throat of the carburetor to be mixed with air, and it would be a very richer condition. So what I'm going to do is, like I said, I'll include a photograph of the jet itself with the number on it, so you'll see how the numbers are put on it. And industry-wide, jets are numbered just like this. They're done either in no matter who manufactures it, it's done the same way, so that if the jets are interchangeable, you know if you're putting a 64 in there, you know you're putting a 64 in there. This does not correlate to a drill size. There is no scientific supporting information that you can take a drill size and drill a jet out. Yes, you can drill it out, but you have no way to determine how much fuel is going to flow through that particular jet based on whatever drill size you ran through it. Now, there are different jet sizes relating to the type of fuel that you're running through the vehicle. Earlier on in our racing applications, we had an engine that we ran on alcohol. Gas jets are totally different from alcohol jets, so we had to jet an alcohol carburetor much differently than a gas carburetor. Alcohol works as also a cooling agent when you're running an engine on alcohol, so you use a lot more, the volume, because of the potency or the volatility of the alcohol is so much greater. It takes more fuel versus gas, just regular gas. So that's just like like I said, a brief overview of what a carburetor does, how it accomplishes getting fuel and air into the engine to complete your combustion cycle, what a jet is, kind of what its job is in the main metering circuit of the carburetor, and we'll put those stills in there for you. If you have any questions, again, please drop those down in the comment section. We'll look at those. We do look at those. We look at all of them, and we respond. If you have a question, please put a question in there. Let us answer those questions for you. And again, if any of you have any interest in an overall video of just the breakdown of a carburetor, the circuits that are involving in the carburetor, comment down there. Let us know if that's something you'd like to see. We'll get a video, a much better productive video for you. Ash will help with that in the future if that's something that you guys want to see, or girls. All right, I'm going to step out from behind this camera. We're going to go to the other camera and get some footage over here at the Bel Air. I'm going to show you some other techniques about how to remove the fuel bowls if you're going to do this on the vehicle. What we're actually going to do is remove the carburetor from the vehicle and do this on the bench instead of on the vehicle. So we'll be right back with that moving over to the Bel Air. All right, Mechanicsville crew, we've moved over to the Bel Air. I'm gonna flip the camera around here, and I've also got a still camera running, just one on a tripod running, so you can see the overview of what we're doing. I'm gonna show you a little bit about if we were gonna leave this on the car, how to drain the fuel out of the bowls and not have it everywhere. But like I said, we're gonna do all these jet changes on the bench, so there's not really a need to do that. But I want to show you a way to get the fuel out of the bowl so you can do this on the car yourself. Most of the Holley carburetor fuel bowls, which are here, this is a fuel bowl here, and then you have one on the back. This being a 4-barrel carburetor, because we have 4 different inlets through the throat of the carburetor. As you can see, as we talked about earlier, let me move this air cleaner thing. You can see that the diameter of the opening of the throat of the carburetor versus where it goes through the middle of it narrows significantly before it opens up down at the bottom where the throttle blades are. That is the venturi of the carburetor. That's what actually causes that air to speed up during the intake of the air and the fuel mixture. So if we were going to leave this carburetor on the car, most of the Holley carburetors have fuel bowl screws that are actually, they're slotted. You will find some of them that have a 5/16, you can use like a little 5/16 nut driver, but basically a flathead screwdriver is what you would use to take out the fuel bowl screws here. Now, if we were going to leave this on the vehicle, we would remove one of the bottom screws here on either side of the bowl. See if I can get a picture down there. And we would loosen it up significantly. And then we would use this tool that my pops made, which is a catch can, and we would get this underneath. We would place this underneath the screw of the fuel bowl, and then once we removed the screw, we would allow all of the fuel that's captured within the fuel bowl here to escape through that hole, and then we would not have a big amount of fuel, a large amount of fuel here when we broke the gasket loose to spill out onto the intake. To further prevent that, we're just going to take this off of the car and do the jet changes on the bench. So we'll get back to you in a second when we get the carburetor off of the car and get it on the bench. All right, crew, don't kill me. I know the camera shut off during the removal of the carburetor. I'll try to rectify that in the future when we put it back on the car. We moved over here to the bench. We're gonna get a good close-up of the carburetor here on the bench, and then we're gonna pull the fuel bowls off of it. All right, so we've got a fixture here that Dad built to mount in a vise to hold the carburetor. This helps when you're working on a carburetor. It just keeps it up here good and high where you can see everything in good light. We're going to remove these screws, get the fuel bowl off of it, and then we're going to check and see what jets are in the carburetor. And then based on what we saw, the plug, and I'll get Ash to pop that picture back up there again. Based on what we saw, we're going to jet this carburetor down probably about 2 numbers all the way around. So we're going to make it square, meaning that all the jets inside the carburetor, both in the primary and secondaries, are going to be the same size. So that hopefully is going to clear up some of that sootiness on the spark plugs, and we'll get to that here in a second. Okay. All right, we're taking the fuel bowl off right here, and what we've revealed here behind the fuel bowl is the metering block. This is a vent for the fuel bowl, which comes out here. Again, that's what allows atmospheric pressure to get on top of the fuel. We have the back side of the power valve, and we got the jets right here. I'm gonna get the other phone and get a good close-up view of that. What I've also seen is right here is where we have a brass float. It's caused a little bit where the car has sat for a minute, has caused a little bit of tarnish on the jets and the back of the power valve. We'll get that cleaned up before we put it back together, but I'm going to take the jets out, which are located right here in the bottom of the metering block. I'm going to take the jets out, let you get a look at those and see what size they are. All right, we're back. Got the jets pulled out of the metering block here, and we're going to take a look at these and see what they are. That looks like a 62 jet. And another 62. So we'll have to check the jet box and see what we've got as far as going down in size. And we'll check that jet box here in a second, but we're gonna turn the carburetor around and pull the back bowl off.
Got a square in there.
Yeah.
Pull that out part of the way, don't pull it all the way.
Yeah.
Alright, probably hold it anyway. Oh, them things look perfect. I made them at Reynolds.
Okay, there's a demonstration of the catch tube that we were talking about, using it on the vehicle. I actually used it here to demonstrate it for you, to catch the fuel that escaped the fuel bowl here on the back side of the carburetor. It contained the fuel, kept the mess down. We don't have fuel leaking all over the floor, or in the case that it would be on the car, we don't have fuel leaking all over the car. In this instance, since I've already got the fuel bowl disconnected from the feed line, I'm not going to risk breaking this seal loose here that I've established on this fuel bowl. So we're just going to leave it intact and pull the bowl and the line off at the same time. All right, here we've removed the bowl on the back of the carburetor. We've revealed another metering plate and the two jets that are back here. The screw that you see associated with the float here is how you adjust the float level on a Holley carburetor. This determines how much fuel actually flows through the inlet past the needle and seat and filling the bowl up and moving the float up and down, and that's what keeps your fuel level in there. To check that, you remove this screw while the car is running, and you just want a little tiny bit of fuel to leak out of this screw hole here. So if you need to adjust the fuel level, you do that through this nut and bolt, or nut and screw up here. All right. All right, what we've determined here, looking at our jet configuration, is that we actually don't have enough to step down the front side. Like I said, we were gonna leave these as 62s. What we're gonna go to is maybe a 65, which would correspond to your jet map up here. So we've got a couple of 65s in here. So what we'll do is we'll get the carburetor cleaned up. We'll take these 65s, make sure they're nice and cleaned up. We'll get some new gaskets, and we'll come back in a little bit. I don't think we'll be able to finish this today, but we'll come back in a little bit with some new gaskets, get these jets in here, get the carburetor adjusted, get it back on the Bel Air, and get it cranked up for you. Hey, what's up, Mechanicsville crew? Back at you again. Here in Pop's garage, we're working on the Bel Air again. We're gonna pick up from the video we left off the other day in the jet change. To bring you up to date here in a few minutes, we're gonna show that jet change on the bench, and then we're gonna put the carburetor back on the car and get it cranked up, I hope, today. While I've got a minute here, check it out. Came in the mail the other day. All you have to do is hit the link in the description of the video, order yours, and you too can be an official Mechanicsville crew member, okay? We got some new crew member shirts. We've got the OG shirts with nothing on the back, but we got crew member shirts. Get your crew member shirt and be part of the Mechanicsville crew. We're here on the bench with the carburetor again. We've got it nice and clean, put back together. We've already put the jets back in the front bowl, secured the front bowl with a new gasket. We've cleaned the metering block up, placed it back on the carburetor, and I'm preparing to put new jets in the carburetor in the metering block. Now this is what we were referring to in the earlier part of the video as a jet. It has a predetermined circumference of this hole, or diameter of this hole here, and it doesn't necessarily, as I discussed before, correlate to a drill size or a particular size. It's the flow rate of the jet, how much fluid can pass through it. So we found out that we had a rather rich secondary side of the carburetor, so we're gonna bump these down a little bit. We're going from a 67 to a 65. We'll see if we can get a still picture up there for you of the 65 jet. So once you get to your carburetor to this point, you've got the fuel ball off, the fuel's drained out of it. You remove the old jets from the ports here in the bottom of the metering block. Then it's just merely replacing them by putting them back in those holes. Always double check your numbers. Make sure that you have a pair. That means a matched pair. They are both the same number. These are both 65s. The fronts were 62, so I'm gonna put a pair of 65s in here. So it just takes a flathead screwdriver like this. Make sure that the blade is wide enough that you can cross the cross section of the jet itself. You don't wanna have too small a screwdriver, too small a blade in there, so you risk the chance of like nicking it or knocking some metal off of it, then will be circulated through your carburetor. These do not have to be Gorilla tight, but they do need to be secured into the jet threads. Like I said, you need to have those secure, but you don't have to try to wring them off. Just double check yourself and make sure they're secure. Okay, we have the bowl back here. We've cleaned the gasket surface off, made sure that there's no contamination of the gasket surface. The float moves free and easy. We're all clean, nice and clean. We're getting ready to mount the bowl back onto the body of the carburetor. As I said in the first video, I didn't want to compromise the seal that I have here on this inlet pipe, so I left it all together. Also, you have an accelerator pump arm that's attached to the throttle that also activates the accelerator pump by this lever right here that goes up and down. Make sure that when you put the bowl back on the body of the carburetor that you hold this arm up and get the accelerator pump arm underneath it, or your accelerator pump won't work correctly. We have bowl gaskets here for the screws. We've got those in place. We're just going to start a screw in here by hand to hold the bowl on there. We want to make sure that it doesn't drop off of the carburetor till we get all the screws started. If these gaskets, the bowl gaskets, have been compromised, you would want to put new gaskets on there. That's a potential for a leak. And again, it just takes a flathead screwdriver in this instance. I did say earlier in the video that sometimes you'll find a carburetor that has like a 5/16 nut driver for these screws are headed for a nut driver. In this instance, this is like a factory Holley bowl screw here, so it does require only a flathead screwdriver to put those in. With these being fresh gaskets, you want to get a pretty good squish on the gasket. You can tell this is a lot of feel that you're going to have. You develop over time. You want to make sure that that gasket is squished properly so you get a good seal all the way around the bowl. You don't have a potential for leaks. And just get it good and tight. All right, I'll work on getting the inlet pipe put back together over here, and we'll do some more checks on the bench here, and the next time I pick you up, we'll be over here at the car, hopefully with it. All right, crew, we're back at the Bel Air. We've got the carburetor mounted back on the vehicle. I've got another camera running. Ash will probably have that video kind of sped up to show you the process of getting it running, getting it back on the vehicle. All right, here is the carburetor mounted back on the vehicle. We've got it all hooked up, our vacuum lines, everything. We're going to energize the fuel pump here and check for leaks. So stand by. Okay, you may be able to hear this, you may not be able to hear it, but you can hear the fuel pump running. We do have physical pressure at the regulator. We're checking for leaks at all of the points that we had apart. We don't have any leaks at the bowls. We're checking here, we don't have any leaks at the bowls. If we do a little, okay, we've already got fuel filled to the bowls. We'll see if we can get this babe to run now. Turn the fan on.
Okay, what you're gonna see Dad do is adjust the throttle stop just a little bit here. Just a little bit more. Okay, basically that is just giving you a throttle stop to give it enough for the engine to idle at a specific RPM for you. All right, now if we were going to adjust the fuel float level, we would take a screwdriver and remove this screw right here. Remember in the previous video I said that you would want to have just a little bit of fuel trickling out of the bowl. You don't want it just pouring out of the bowl. As you can see, it's right at the edge of the fuel bowl. It probably could use just a little bit of an adjustment that I may show you later on. To do that, to affect that adjustment, you would use this tool right here, which is a needle and seat adjuster. You place it on top of the nut, loosen the nut, either screw the stop down for the needle or open it up to allow fuel to come out of the bowl. Right now, I think we're doing really good with the way, especially with the way it's idling and the way it's picking the throttle up. I don't think there's really a problem with the fuel bolt float level.
It's dead right.
Okay, that one had the fuel running out of it. We may actually adjust this front bowl here a little bit later on, but right now, as far as the carburetor picking up the throttle and accepting the throttle, I don't think we really have an issue with it. All right, guys, this is Commish. We're taking you through changing jets in a carburetor. A pretty intensive Mechanicsville minute. Something that I really intended on to be a very relatively short video. Turned out to be quite an extensive video for you. I hope you enjoyed this. Remember, like, subscribe, and as always, hit that notification bell so you can get notified when we get new content uploaded for you. Check the link in the description of all the videos for the merch. Be an official crew member. And we do have a new t-shirt that dropped that says crew member on it. So you get you some new merch. Like, subscribe, share. And thanks for watching Mechanicsville. All right, crew, we're wrapping up here. We've got the vehicle started again. We've got everything put back like it was. Just kind of wrapping up the video for you. Taking a look at the jet box. I'm going to show you the proper storage of your carburetor components. Okay, as you saw earlier in the video, I had a jet box out here. This is the best way to store and keep your unused jets. Don't ever take the jet and put it on a string or a shower curtain ring or something like that, because that distorts the internal part of the jet. And as we said, that's calibrated to flow a certain amount of fuel through it. And we did replace the ones that were in the secondary side of the carburetor. We stepped down two steps, so we put 65s in there. So we have 62s on the main side, 65s on the back side. I'll get a picture of the jet that we used. Also, there are a lot of moving internal components to a carburetor, and the best way to keep those things I found is like a fish and tackle box here. It keeps all of your stuff organized. You have different power valves and plugs when you want to remove a power valve. You have your your cams, different cams that operate your accelerator pumps at different rates, because it's a cam. Here you have your annular nozzles or squirters. Those come in different sizes. Just anything. This is what I call a track pack. This is what I used to take to the racetrack when we had we were racing full time, and this was just an incidental thing. You know, somebody may need something and you have it. Be a good sportsman and help them out. These were just things that we kept incidentally for just our car, in case we needed something on the quick and on and you don't have a parts house available to you. But keep your carburetor pieces organized. Keep your jets in a box like this. It's mapped on the top. It's mapped on the top here to tell you where the locations of each one of the jets are. And also, when you're changing jets, double check the size. Look at them. They'll have the number on them. All right, crew. Like I said, we're wrapping this up. Ash is going to have a lot of content to put up there for you. A lot of steals, some sped up video, hopefully, of installation and removal processes. But I think this Mechanicsville minute really turned into a longer than a minute, but I think it's good information for you. Give us a comment down on the link below or in the description comment section below, and let us know what you think.